हेलो भाई। ये गड़बड़ हो गया था यार अभी। ये इसमें पता नहीं माइक्रोफोन काम नहीं कर रहा था, बट अभी फाइनली कम काम कर रहा है। तो यार ये प्रॉब्लम का हम सॉल्यूशन देखे। ये हो जाएगा, मतलब कल करते को इसको कोड ही करना है और तो कुछ करना है नहीं। तो आई एम थिंकिंग ऑफ डूइंग दिस प्रॉब्लम। सॉर्ट अ लिंक लिस्ट ऑफ जीरो वंस एंड टूज बाय चेंजिंग लिंक्स। तब ये वाला है कुछ, देखते हैं। तो भाई हम बहुत ज़्यादा टाइम वेस्ट कर देते, तो ये 15 मिनट का है। 15 मिनट से ज़्यादा नहीं। ठीक है। वाह भाई, स्टिकर भी है इसमें। 15 मिनट से ज़्यादा नहीं, ठीक है। तो लिंक लिस्ट में आते हैं। 15 मिनट से ज़्यादा एक क्वेश्चन पे वेस्ट नहीं करना। ओके, लेट्स गो। ये मिटता क्यों नहीं है यार? अब भाई कुछ काम नहीं कर रहा है रात में। आ, तो खोले के बाद लिंक लिस्ट अब मिट रहा है। ओके नाइस। तो फ्लो से कर लेते हैं कनेक्ट अपने आप को, और स्क्रीन पे कर लेते हैं अपना टैबलेट को कास्ट। और क्या है टैबलेट का स्क्रीन ऑन स्क्रीन। ये आ गया। तो छोटा कर लेते हैं इसको, थोड़ा ठीक कर लेते हैं। मतलब क्या ये रहा प्रॉब्लम। देखते प्रॉब्लम क्या है। और टाइम वेस्ट नहीं करना है, तो 15 मिनट ही करना है हमको। तो 15 मिनट का एक टाइमर लगा देते हैं। 5 मिनट तो क्वेश्चन प्रॉब्लम समझने में, और 15 मिनट में अगर हम एल्गोरिदम डेवलप कर लिए तो कोड करेंगे, नहीं तो सॉल्यूशन। तो क्लॉक खुल जा, खुला हुआ है एक्चुअली। तो चलो 15 मिनट है, आखिरी में 5 मिनट ले लेंगे, बार बार लटकवानी टाइमर करें। नहीं, 5 मिनट कर ही लेते हैं। 5 मिनट ये आ गया। क्या है भाई? इजी कैटेगरी का है, ठीक है। सबमिशन रेशियो कितना है इसका? 62.63 है, इजी है, मतलब हो सकता है सर। क्या है गिवन द हेड्स ऑफ टू सिंगली लिस्ट, हेड ए हेड बी। दो सिंगली लिस्ट है, हेड का पॉइंटर दिया हुआ है। रिटर्न द नोड एट विच द टू लिस्ट इंटरसेक्ट, ये नोड को रिटर्न करना है। तो डू आई नीड टू रिटर्न द पॉइंटर टू दिस हेड? आई गेस सो। तो यहाँ रिटर्न द नोड है। ओके, आगे बढ़ो। इफ द टू लिंक लिस्ट हैव नो इंटरसेक्शन एट ऑल, रिटर्न नल। तब दोनों सीधा है अपना अपना, तो नल रिटर्न करना है। ओके। हम्म फॉर एग्जाम्पल द फॉलोइंग टू लिंक लिस्ट बीइंग टू इंटरसेक्ट एट नोड C1, ये सारे वैल्यू यूनिक होंगे। ठीक है। द टेस्ट केसेस are generated such that there are no cycle anywhere in the entire linked list। मतलब जो भी इसमें टेस्ट केस है, अरे भाई मतलब होता है तो किसी में साइकिल वगैरह नहीं है। ओके, ये तो अज्यूम्ड ही रहता है सब मोस्ट ऑफ द प्रॉब्लम में। नोट that the linked list must retain the original structure after the function returns। ओके। कस्टम जज, ये क्या होता है? The inputs to the judge are given as follows। जज मतलब आई गेस द, तो मतलब सारे टेस्ट केस पे रन करता है। योर प्रोग्राम इज नॉट गिवन इन दीज इनपुट्स। क्या? custom judge, the inputs to the judge are given as follows। your program is not given this inputs। तो ठीक है। intersect value, the value of the node where the intersection occur, this is 0 if there is no intersected node। List A the first linked list, list B the second linked list, skip A, number of nodes to skip ahead in list A, starting from the head to get to the intersection point। Skip B, number of nodes to skip in list B starting from the to get to the intersection point, वो दे दिया। और the value of node where the intersection, the value of the node, अच्छा उसका वैल्यू क्या उसके अंदर, दिस इज 0। अच्छा ठीक है। हमको इसका क्या ही करना, मतलब ये तो वो है ना, इसका हमको तो कुछ नहीं करना ना, इसमें हमको इनपुट में ये दिया नहीं है। इट इज़ लाइक पोजीशन ये है, तो वो कुछ करना होता है नहीं। हमको दोनों का सिर्फ हेड दिया है, हमको ये पोजीशन रिटर्न करना है, यही ना। रिटर्न द नोड। यस। तो इनपुट देख लेते हैं, इनपुट इंटर इंटर वैल्यू 8, लिस्ट ए लिस्ट बी, स्किप ए 2 पर स्किप बी को 3 को करना है, इंटरसेक्शन एट 8। इसका एक्सप्लेनेशन है ये। ठीक है समझ गया। तो ये सेम है, नोट का वैल्यू 2 है, लिस्ट ए का वैल्यू है, लिस्ट बी का वैल्यू है, स्किप ए 3 करना है, 3 नोट को स्किप करना है, इसमें 1 को करना है। ठीक है, वेल एंड गुड। ठीक है, ये अलग एग्जाम्पल। सॉल्व कैसे करें? तो वो एक नोट रिटर्न करना है बेसिकली, ओके। और वैल्यू यूनिक से, राइट। तो एक पॉइंटर लेते हैं, इसको आगे बढ़ाते हैं, तो आगे बढ़ाते हैं। एक है कि एक पॉइंटर रखो पूरे को ट्रैवर्स है, आगे बढ़ा, फिर पूरे से ट्रैवर्स करके देखो वैल्यू इक्वल है कि नहीं। आई गेस यूनिक वैल्यूज है, यूनिक वैल्यूज है यार, हम अज्यूम कर रहे हैं यूनिक वैल्यूज है, ऐसा ज़रूरी नहीं है क्या? दवाई खाना है भाई हमको, दवाई का याद आ गया। हाँ, दवाई 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 कहाँ है? एक मिनट भाई, एक मिनट, दवाई मिल जाए। दवाई कहाँ रखती है? fuck, दवाई कहाँ चला गया यार? fuck, फोन का है मेरा। छोड़ो यार, दवाई अभी मिल नहीं रहा। दवाई लिख देते हैं, मुझे याद नहीं। अब 15 मिनट और बचा टाइम मेरे पास। देखते कैसे बन सकता है यार। A1 A2 C1 C2 क्या कर सकते हैं यार? एक नोड, एक पॉइंटर तो बनेगा। अ, दोनों को मूव कराना होगा किसी तरीके से, ताकि जहाँ आई नीड टू मूव देम, ये तो है। दो पॉइंटर लेंगे, एक यहाँ से शुरू होगा, एक यहाँ से इनिशियलाइज होगा, एक यहाँ पे रहेगा, एक यहाँ पे रहेगा। तो हम दोनों में से कोई एक आई गेस रिटर्न कर सकते हैं। और वो कैसे पता चलेगा? क्योंकि वहाँ पे वैल्यू इक्वल होगा, और तो कुछ नहीं होगा नेक्स्ट जाते जाते। हम्म। तो अगर हम इसको एक मूव करें, इसको एक मूव करें, तो एक दो तीन बार मूव करना होगा इसको, एक दो तीन चार बार मूव करना होगा, राइट। दो के बाद है ये, चार के बाद है चौथा पे। मैं एक दो तीन, वही है ना, एक दो तीन, इसमें एक ही मूव करना है, एक तो मूव करना है। अगर एक भी नहीं मूव करना है मतलब नल है ना, तब क्या मतलब एक ही लिस्ट है? तब तो अ, अगर एक नल है, इसका मतलब क्या हुआ? वो नोड, वो लिस्ट है ही नहीं। अच्छा, मतलब अगर कोई भी दोनों में से कोई एक भी पॉइंटर, अभी क्या है पैरामीटर्स, हेड ए हेड बी, अगर हेड ए नल हुआ और हेड बी नल हुआ, तो रिटर्न कर दो। नर पीटीआर, ये तो ठीक है, ये हो जाएगा। तो सबसे बेसिक कैसे है, और कैसे कर सकते कर, इतना मूव करे वो क्लियर नहीं, हाउ मच स्टेप्स दैट आई मूव नीड टू मूव स्लो एंड फास्ट इज नॉट क्लियर। हम्म। एक ब्रूट कर सकते हैं कि सारे का वैल्यू को पुश कर दो, सारे का वैल्यू को पुश कर दो, जहाँ पे वैल्यू मैच हो रहा है दोनों एरे को कंपेयर करो। उसके बाद जहाँ पे बाइनरी सर्च से भी कर सकते हो सर्च, नहीं मतलब सॉर्टेड होगा, सॉर्ट कर लो एन लॉग एन में, बाइनरी सर्च से कर लो फिर कंपेयर सी वन मतलब, नहीं नहीं, दो एरे दिया हुआ है, दोनों में कौन से इंडेक्स में मैच हो रहा है वो बताना है, तो एन स्क्वायर तो लगेगा ही। उसके बाद फिर इसमें थर्ड पे पता चल गया तो इसको थर्ड पे जाके कर दो, इसके फोर्थ पे पता चल गया तो इसको फोर्थ से जाके कर दो। हम्म, और लिखा है कि could you write a solution that runs in OOOM plus n time and use only m, क्या है यहाँ पे, तो दोनों का m एलिमेंट्स हो गए, इसमें n एलिमेंट्स हो गए, आई गेस या एक बार तो हाँ,
So let's continue with our playlist. So before that, hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we will be solving today is finding the intersection point of a given Y linked list. So what is the problem exactly stating? It's stating that you'll be given two linked lists. So basically head 1 and head 2. So if I look at the first linked list, this one is the first linked list. If I look at the second linked list, this is the second linked list. Now your task is to figure out the first common node. Can I say this entire portion is the common portion between the first linked list and the second linked list? So this is the first common node. This is the second common node and the third common node. So your task is to return the first common node or the first intersecting point of two given linked list. But you might be thinking, hey, what if they never collide? What if you are given an example, something like this? This can be a linked list, and then I can have another linked list, something like this. They're never colliding. It's not a Y linked list. In this case, you'll be returning null, stating that they never collide. In case they collide, then you will be returning the first node. Got it? So if this problem comes up in an interview, we will be starting off with the extreme right solution. And what will be that? Can I say this? That I'm looking for a node which is in the linked list 1 and which is in the linked list 2. So can I do this? I will go through the first linked list and probably memorize the nodes that I've seen or that are there in the linked list 1. Just remember in your memory somewhere. And then what you'll do is, you will again traverse the second linked list. And if you see any node which you memorized has been visited again, that means this is your first point. How can you memorize things? How can you store it? Yes, we will be using the concept of hashing. Very, very important concept. So what I can do is, I can declare a map data structure and I can store the node, the entire node as the key. Do not store the value, please. Why? Because if you see a 4 here, there's a 4 here as well. So if you store the values, it will be wrong. Instead of it, try to store the node. And along with it, maybe you can store integer, boolean, whatever you wish to do. Let's take two variables, temp1 and temp2, where temp1 will be at the starting point of linked list 1 and temp2 will be at the starting point of linked list 2. Let's probably traverse the first linked list. So what I'll do is I'll start traversing. So whatever is the first node, let's put it over here and say 1 and then move it. Whatever is your second node, again put it and move. Let's go to the next. We have 4. Let's try to put it and move. Let's again take this 6 and put it and move. Let's take 2 and put it and move. And then temporary will reach null. The moment you reach null, that means the traversal on the first linked list is completed. Once it is completed, what I can do is I can try to take this temporary off, and I'll do the traversal of the second linked list. So after the first traversal, all the nodes of the linked list 1 has been stored into the map data structure. Now your next job is to go through the second linked list and check if there's a repeating node or not. So let's do it. We're over here. Is this particular node in the map data structure? We don't have it. Yes, we have a node with value 1. We have it, but that is this node. That is why I said please store the entire node. Got it? So it is not there. Let's move to the next. When I move to the next, it is also not there in the map. Let's move to the next. This one is not there in the map. Let's move to the next. This one is not there in the map. Let's move to the next. And we will see that this exact same node is over here in the map if it is there. And while traversing, the first node, which is repeating, will be your first point of intersection. So what you can do is, you can stop over here and you can straight away return. In case you traverse, and you end up reaching null, that means they were separate linked lists and you did not find an intersecting point. Got it? So this will be the simple hashing method. So let's quickly write down the pseudocode. In case you want the C++, Java, Python, or JavaScript code, all the links will be in the description. Initially, we will be taking a map data structure, which will be storing a node and an integer. Right after that, we'll be taking a temporary, placing it at the head 1, okay? And let's traverse on the first linked list, which is basically till it reaches null. And let's say map.put or whatever, according to your language. Hey, map, can you store this entire node, not the data, entire node? And after that, your last temp, hey, can you move ahead? Temp.next. Perfect. This is my first traversal, which will basically store all the nodes in your memory. Let's do the second traversal. I can say temporary will be head again, but this time head 2. Let's do a traversal again. So temp is not equal to null, and I will be traversing. What will I check? I will check, hey map, do you have this? Probably find whatever according to your language. Hey map, do you have this temporary? If he says, yes, I do have it. Yes, I do have it. That means this is your first repeating node, which means this is your intersection point. Return this particular temp. Perfect. Or else, you can straight away go to the next node, which is temporary of next. End this one, and if the entire traversal is completed, and you never executed this if statement, which means, yes, there were no common or repeating or intersection point. Thereby, I will end up returning null. What will be the time complexity? Can I say that the first traversal will be taking big O of n into whatever time your map takes? If your map takes logarithmic, it will be n log n. If your map takes constant time, it will be n into 1. Depends on your map's time complexity. I've discussed this in depth in the hashing lecture. Go back and watch it. Again, the same thing over here. Big O of n2. Probably this will be n1. n2 into if your map is taking logarithmic, if your map is taking big O of 1, depends on that. So can I say that the overall time complexity will be big O of n1 into on the map plus big O of n2 into whatever the map takes, logarithmic n or big O of 1, depending on what language are you using, what kind of map you are using. What will be the space complexity? If I'm going through the first linked list and storing everything, it will be big O of n1. If I go through the second linked list and store everything, it will be big O of n2, depending on which linked list you are storing. Like in our example, we took this entire linked list and we stored it. Thereby, the space used will be big O of n1. You could have done in the opposite manner. You could have stored this entire one and then you could have traversed in this one. Depending on that, it doesn't matter because what if In the worst case, you might have same length linked list, so it doesn't matter. So this will be your time complexity and the space complexity. This is where the interviewer will not be happy because we're using an external space to store these things. He'll ask you to optimize this. So we need to optimize the space complexity. This gives me an idea that, hey, you cannot store the nodes. You need to solve it during the traversal itself. Can I solve it during the traversal? Okay. If T1 is standing here, which is the head one, and if T2 is standing here, can I straight away draw a comparison? I cannot, because this is the shorter linked list and this is the longer linked list. Can I do a comparison? I cannot. For comparison to happen, T2 should stand here and I should compare them and then move T1 here and T2 here, compare them, move T1 and T2 here, and the comparison will succeed. But they need to be standing at the same vertical level. I cannot stand 2 steps behind and have a comparison done. Stand 2 steps behind, 2 steps. Okay? Can I move T2 by 2 steps and make it stand here and then start the comparison and then start the comparison and then do the comparison? Can I do this? Yes, I can. So my goal will be to make sure whichever is the longer linked list, I will make sure it goes in the same level as the shorter one. I'll try to do that. How can I do that? Let's take T1. Let's take T2. Okay. Let's first traverse in the first linked list and compute the length of that linked list. So N1 can be taken as 0. T1 moves 1. T1 moves 2. T1 moves 3. T1 moves 4. T1 moves 5. T1 moves reaches null. So eventually the length of the linked list is 5. Can I do the same for this one? I can. And what will be the length? 7. So when T2 will reach here, the length will be 7. You can simply traverse in both the linked list and find out the length. Once you're done for the length, what is the next job? Can I say one of them will definitely be larger? If they're equal, it's fine. You just start. If they're equal, you start comparing. But if they're not equal, which is in this case, N1 is 5, N2 is 7. What is the difference? N2 minus N1? 2. 2 is the difference. If the difference is 2, what you will do is, you will take T2 and make it move by D steps. 1 step, 2 step. Now T2 stands at the same level as T1 does. T1 is at head, standing at the same level. Once you have done this, now you can do a simultaneous movement. T1, not equal, do a simultaneous movement. Is it equal, not equal, do a simultaneous movement. Is it equal? Yes, it is equal. Stop then and there and say that this is my collision node and you can straight away return it. Quite simple, isn't it? So can I write down the code? I can. Maybe I can take T1 to be head and I can take N1 to be 0 and I can take T2 to be head and N2 to be 0. Let's do traversal to compute the length, which is T1 is not equal to null. And you can say N1 plus plus and T1 can go to T1 dot next. Very simple. At the same time, you can do it for the second linked list as well. Let's move it. And you can do N2 plus plus and T2 can go to T2 dot next. Once you've figured out the length, what is your next job? The next job is to make sure that the longer linked list traverse the remaining distance, right? So can I say, hey, what if N1 is smaller than N2? In that case, the linked list 2 will traverse, right? So maybe I can write a function where I say collision point of, I need to find it of head 1, head 2. I'm assuming that this is the greater linked list, this is the greater linked list, and this is the smaller one, because that is what I'm writing over here. And I'm saying, please cover a distance of N2 minus N1. Please cover a distance of N2 minus N1 and find me out the collision point. Or else I will say, hey, return collision point of, this time, the smaller is head 2. The linked list 2 is the smaller and can be equal as well, head 1 and N1 minus N2. So what I've done is, I've written down a function, collision point, which takes the smaller, which takes the greater, and it also takes the distance that you have to traverse, right? And either of them will return you the collision point. So I need to write a function collision point that is accepting a smaller linked list head, that is accepting a larger linked list head, and the difference of distance between them, right? So if I go back, what do I need to write? I need to write a function which starts at the larger linked list, covers the D steps. Once it is aligned, starts comparing, and the moment it compares and finds the same, it returns that collision point. Otherwise, it will reach null. Otherwise, it will simultaneously reach null. Got it? So let's quickly write down the function collision point. Collision point can be written as, it'll take a smaller linked list head. So maybe I can say small head or small, or maybe let's call it temporary 1. Let's take temporary 2 and D. Perfect. What is the first thing? The larger will go at the same level. So let's move it D steps while D minus minus and T2 equal to T2 dot next. So now T1 and T2 are at the same level. Let's start comparing. If they're same, I will stop then there. If they're same, I will stop. Otherwise, I will keep moving them. T1 goes to T1 dot next and T2 goes to T2 dot next. And whenever they meet, they will somehow meet. If they're not colliding, it will be null and null will be equal to null. So you will be returning T1 or T2, whichever you want to return, you can, because you can return any one of them because the while loop will only terminate when they're equal. They can be equal at a colliding node or they can be equal at a null. So you can return straight away. So this will be a collision point and either head 1 is the smaller and head 2 is the larger or the opposite. Depending on that, this function will execute for both of them. You don't have to write repeating lines of code. Got that? So time to discuss the time complexity. This is taking bgo of N1. This is taking bgo of N2 for sure because I'm traversing the entire linked list in order to find out the length. After that, this D is nothing but bgo of N2 minus N1, assuming N2 is greater. Assuming, because that is how much it will traverse. After that, I'm doing another while loop. How much will this be? Let's go back to the example. I'm standing over here. I will end up traversing these nodes in case it doesn't collide, which is basically the shorter length, So I can say another bgo of n1. So I have to write it as bgo of n1 plus bgo of n2 plus bgo of n2 minus n1 plus bgo of n1 minus n1 plus n1 goes. So it's bgo of n1 plus 2 n2. Can I write this? I can. So this will be my time complexity and the space complexity will be bgo of 1 because I'm not using any external space. This is where the interviewer will not be happy with this time complexity and he will ask you to optimize it. So the optimal approach will not be using any fancy algorithm. Rather, we will be traversing through the linked list and we will find out a way to find the common intersection point. Let's see how. We need to traverse both the linked list together. So we will be taking temporary 1 and temporary 2. Remember, we will not alter the head. We will take two separate variables. Temporary 1 placed at the head 1 of the linked list 1. Temporary 2 placed at the head 2 of the linked list 2. Got it? After that, we will simultaneously move them 1, 1, 1 place. That is basically traverse together. Temporary 1 will go here. At the same time, temporary 2 will go here. Temporary 1 will go here. At the same time, temporary 2 will go here. After that, temporary 1 will go here. Temporary 2 will go here. At the same time, temporary 1 will go here. And temporary 2 will go here. Stop here. Stop. Okay. And I will erase everything. So you stop at a point when you reach the last node. Why? Because after this movement, temporary 1 will reach null. Temporary 1 will reach null. So remember, whenever you're traversing and any of the pointers list and we will find out a way to find the common intersection point. Let's see how. We need to traverse both the linked lists together. So we will be taking temporary 1 and temporary 2. Remember, we will not alter the head. We will take two separate variables. Temporary 1 placed at the head 1 of the linked list 1. Temporary 2 placed at the head 2 of the linked list 2. Got it? After that, we will simultaneously move them 1, 1, 1 place. That is basically traverse together. Temporary 1 will go here. At the same time, temporary 2 will go here. Temporary 1 will go here. At the same time, temporary 2 will go here. After that, temporary 1 will go here. Temporary 2 will go here. At the same time, temporary 1 will go here. And temporary 2 will go here. Stop here. Stop. Okay. And I will erase everything. So you stop at a point when you reach the last node. Why? Because after this movement, temporary 1 will reach null. Temporary 1 will reach null. So remember, whenever you're traversing and any of the pointers reaches null, you will not take it to null. Instead, you will take temporary 1 to second head opposite the other linked list head. So you'll basically say temporary 1, go to the head of the other one. So temporary 1 will be over here. and you will move temporary 2 as it is. So this is how the movement will look like after the step. I'll explain you why. Again, keep moving them one step, one step. Next step will be temporary 1 will move 1, temporary 2 will move 2 places. Sorry, 1 place. After that, again do the same thing. Temporary 1 moves here, and temporary 2 will go to the head 1. Why? Because temporary 2 was going to be null. And if you remember, I told you, while traversing, if anyone reaches null, it goes to the opposite. As temporary 1 went to the opposite, temporary 2 will also go to the opposite. Just take them to the opposite. Perfect. If you carefully observe, what has happened now is they are aligned. They're aligned on the same, isn't it? Let's perform the next steps, but before that, I'll erase this. Again, take them one step together. So temporary 1 will be here, and temporary 2 will be here. Again, take them one step together. Temporary 1 is here, temporary 2 is here. The first point of contact, the first point of similarity is where you will say that this is the repeating node, or this is the first node where my intersection starts. And you straight away return this node. Why does it work? I'll be giving you a proof. But as of now, understand that we traverse, and if the temporary 1 reaches the null, we take it to the opposite linked list. If temporary 2 reaches the null, we take it to the opposite and then move it. Let's talk about some edge cases before I move on to the code. So if you look at the example that we did take, the length of L1 was not equivalent to the length of L2. And that is the reason T1, which is basically temporary 1 that we took at head 1, and temporary 2 that we took at head 2, they were traversing in a different manner. What does it mean? Temporary 1 reached the last node before the temporary 2 did. Why? Because there was a difference of length. There was a difference of length of 2. That is why T1 reached the last node. And then you basically took it to the opposite end when it reached the last node. That is what you did. But what if the length of both the linked lists are same? What will happen in that case? You can keep T1 here, T2 here. Let's traverse. T1 and T2 will traverse simultaneously. 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 And if you observe, they will collide. They will not reach the end. You don't need to move them to the opposite heads. They will collide, and this will be your intersection point. So if length is equal, you don't need to do the opposite. You don't have to write separate conditions for it. What I'm trying to explain is, in case they are of same length, it will collide before you move to the end. Got it? If there is a collision point, obviously. Let's look at one more example. We have L1 and we have L2. They're never colliding, right? So if they're not colliding, how do we figure out that we need to stop traversing? Because they're not colliding. There's no collision node. How do we stop? Let's understand how the algorithm works over here. We take a temporary 1, place it at the head of the linked list 1. We take a temporary 2, place it at the head of the linked list 2. Let's start traversing. T1 and T2 will simultaneously move one place, right? And again, T1 and T2 will simultaneously move one place. At this moment, when T1 moves to null, you say, hey, go to the opposite head. Go to the opposite head. So T1 will be here, and T2 will move. So T1 moves to the front, and T2 will move here. Perfect. I'll just erase this. After this, again, they will be moving simultaneously. T1 moves here, T2 moves here. After that, again, they will move simultaneously. T1 moves here, and T2 moves to the opposite head. And if you carefully observe, they are again aligned. They are again aligned. The same thing happened over here as well. The same thing is happening over here as well. Let's try moving them. T1 and T2 will move together. T1 and T2 will move together. I will come to that. Let's first write down the code. Get the algorithm or get this. I will take a temporary 2 and place it. If the collision point, you can the first node. What if you're given that this will take care, but just in case it is for the first time. In that case, I will end up returning T1 or T2. If I say the difference seriously to the next node, T1 from the other one. It's time to understand that why are temp1 and temp2 aligning at the same level load after some steps of traversal. Let's understand it. T1 initially is at head 1. T2 initially is at head 2. What is the difference between them? If I say the difference is D, can I say it is 2? Why? Because I need to take 2 steps in order to reach T1. T2 is 2 steps behind T1. Understood? Let's perform the algorithm. T1 and T2 moves simultaneously to the next node. T1 and T2 again moves simultaneously to the next node. T1 and T2 again moves simultaneously to the next node. T1 and T2 again moves simultaneously to the next node. And this is happening because of these 2 lines, right? After that, what will happen? Again, T1 will move to the next and T2 will move to the next. Let's erase all of these things. Now, whenever T1 reaches null, whenever T1 reaches null, what happens? Let's analyze. You said T1 equal to T1 dot next. It will reach null, right? After that, it will go ahead and check if it is null. If it is null, it ends up going to head 2. It ends up going to head 2. But before that, let's visualize something. How many steps is T2 behind T1? 1, 2. It is still 2 steps behind T1. So T1 goes here, goes to the opposite head. So can I say T2 is still 2 steps behind, right? And T1 is at the head, which is still 2 steps behind this particular place, right? What happens? T2 takes 1 step, takes 2 steps. Whenever it reaches null, it means it will reach here. It means it will reach here, which means T2 will take 2 steps to reach here. And that's how many T1 will take. That is why they align. The proof is very simple. Since you're moving them simultaneously, T2 is bound to be same number of steps behind whenever T1 reaches the opposite head. So after this, you again move T1 and T2. T2 reaches here. Covers up. And then T2 reaches here. T1 reaches here. Here means here. So hence they align. Because it was these steps behind, you made sure that this T1 goes to the opposite so that you can cover that these steps. That is the proof behind this algorithm. So what will be the time complexity for this particular algorithm? Can I say big O of N1 plus N2? Why can I say that? We took T1, right? Which is null. Same code that I've written on the